This guidance video is for the worksheet in the polynomials unit called Adding and Subtracting Vertically. So class, you're going to learn in your notes that there are two primary methods for adding and subtracting polynomials, and they are the vertical method and the horizontal method. I'm going to teach you both methods, and then you can decide which one you prefer and use that one. So here's our essential question for today. How do I add or subtract polynomials using the vertical method? So we're going to learn the vertical method first. It takes a little bit longer to set up the vertical method, but for some people it's just easier to organize things, and it helps them make less mistakes. Before we do that, we got some review. Classify the following polynomials as monomial, binomial, trinomial, or polynomial. Remember in the last worksheet I talked about how if you call something a binomial or a trinomial, it is automatically also a polynomial. If it has more than 3 terms, then you would only write polynomial. And since monomial only has 1 term, that is not considered a polynomial. And then write the degree. So your setup here is, for the first one, let me get a colored pen here. The first one is, here's my equation. You can see it's this one's already in standard form. My name, this is 1, 2, 3 terms, so my name would be trinomial, and also I could call it a polynomial, so I'd write both of those. And the degree, remember, look at each term, each monomial inside this polynomial and check the degree. And this first term, we've got a cubed variable, so that's a degree of 3, degree of 2, degree of 0. There's no degree on a constant, so that would be a third degree. Why don't you pause the video for a moment and try the other 4, and I'll give you those answers in a moment. Alright, so let's take a look at the next one. This next one would be a polynomial. There are 4 terms, and the highest degree is 4, so a degree of 4. Next two, hang on a sec, I can't actually get those to show up on my screen, so give me a moment. Alright, this one we have 1 term only. There's nothing being added or subtracted to this term. That's a monomial. That means it's not a polynomial, so a monomial, degree 2. And then this next one, 1, 2 terms, that's a binomial. It's also a polynomial. You could call it either one of those. The degree on the constant is 0, and the degree on this first term, remember, even though this variable doesn't have an exponent, we know that an exponent is implied. There is a 1 there, just like there's a 1 in front of any variable. If there's no coefficient, then we assume there is a 1, because 1 times anything doesn't change it, and x to the first power is exactly the same as x. So this is a binomial with a degree of 1. Alright, let's move on through this. Giving you some help here. How to use the vertical method to add or subtract polynomials. You can read through this. It's just a reminder of what you've already covered in your notes. Notice with vertical adding and subtracting, you line up all the same variable and exponent terms in the same column and just add them together. And if you end up in this case with terms that only have 1 like term, like there is no other term that's the same as x cubed, you'll see no x cubed with this. So because of that, we don't have anything to add or subtract, and it stays the same. Last thing you'll see here, very important. When you're adding, you notice when we're adding this other polynomial, I'll put a little underline right here, you'll see that none of the signs of the terms change. You just rewrite them exactly the way you see them. Positive 7, positive 4, positive 3. But when you are subtracting a polynomial, we talked about this in the notes. Think about this as you're going to subtract each of these terms. So you're going to rewrite this expression before you start to add like terms. All these terms stay the same because there is no minus sign in the front. But here, because there's a minus sign, this is minus 3x to the 5th. This is minus 7x to the 4th. And this is minus a negative 2x, and subtracting a negative means you add it. And then minus a positive 4. Another way to think about this is, imagine there's a 1 here, which technically there is, and you have to distribute this negative 1 to all of these terms. You can see that what it does is it flips the sign of every one of these. It changes the sign to the opposite value. Make yourself do this, and now it's easy to add like terms. If you try to do this in your head on a complicated polynomial, you will almost always make a mistake on at least one of these signs, and I got to tell you, making that one mistake will give you a wrong answer even if everything else in the equation is correct. So now take a look, vertical method. We're going to take all the highest exponents, line them up. We got 3x to the 5th and negative 3x to the 5th. Line up all the exponents, line up the constants. So this is, now once you line these up, all you have to do is look at the coefficients. This is 3 minus 3 is 0. That means there is no term with x to the 5th. Nothing minus 7 is negative 7. 4 plus nothing is 4. 9 plus 2 is 11. And negative 9 minus 4 is negative 13. And this is the vertical method of combining polynomials by adding and subtracting. So I will quickly go through one example for you here. I'm going to rewrite my expression. So in this case I'm going to write, actually I won't even do this one for you because it's adding, it's pretty simple. Just rewrite all your terms, and remember you are not changing any of the signs because there's no minus sign in front of either of these polynomials. So I'm going to rewrite this and leave all my signs the same because this plus doesn't change any sign. I'll leave this up to you to put these in columns, add them up, and circle or put a box around your final answer. I'll put that as a note to some of you who are half sleeping right now. Just make sure that when you get to the final part, you put your answer in a box or a circle. All right. Let's do a little trickier one as an example. Let me see if I can find a subtraction. Here it is. So your example for this one. In this case, when you rewrite it, you recognize this minus sign is going to change the sign to opposite for both of these terms. So I've got 3a squared plus 1. Those signs don't change because there's a plus over here, not a minus. And then I'm going to write subtract 4, and we're going to change that sign also, subtract 2a. So this changes the sign. Please don't think it turns everything to negative. If this was a minus 2a squared, that negative sign or subtraction sign would multiply negative 1 times negative 2, and you'd end up with positive 2. So it changes the signs to opposite. And now we're going to make our buckets. So let's do that. I've got my buckets. Looks like I only have 2 of them. We'll see if we need more. I've got 3a squared. That's a like term. That goes together with negative 2a squared. I'm going to cross those off. I've got no a term, so now I just go to my coefficients. I've got positive 1. Now if you want to write a plus here to make it more clear to you, that's totally fine. That's a positive 1. We're subtracting 4 here. And now let's go ahead and do this. 3 minus 2 is 1. So I can write 1a squared, or I can just write a squared because 1 just means a squared. It doesn't actually change the value. But if you want to write 1a squared, I will never mark that wrong. And then we've got 1 minus 4 is negative 3. So there is our answer to question number 6. All right, the rest of these you should be able to do on your own. Check your answer key. Be prepared to ask questions in class. The rest of these, they get a little more complicated. You should be able to handle all of them. Take a look at number 12. I'll give you some guidance there. It says, put a check mark next to each expression that is equivalent to. Equivalent to. You should have learned that term last year. Equivalent means equal to or the same as. And when you look at these, some of you can do this in your head, and I'm going to ask you, because we're going to get more complicated expressions later on, I would strongly suggest you show your work always. Because when it comes to test days, if you don't show your work on this, if you just check boxes, you're not going to get full credit for it. You got to show your work. And the way we do this is we look at this and say, hey, why do we even learn to simplify things in the first place? Because when you simplify, if two expressions are the same, they will look identical. Now you know right now, this doesn't look like any of these expressions, but if I simplify this, watch what I'm going to do. I'm going to do this really quick by using the horizontal method, but I will show you that I've got like terms right here. So 4x minus 6x, 4 minus 6 is negative 2, so I've got negative 2x. You can do this the vertical method. I'm just saving myself a little bit of time. And then here's my next one. I will double underline that. I've got positive 3 plus 10, that's positive 13. So this is my simplified form of this polynomial. Why do we do that? Because it's going to make it a lot easier to figure out whether they match. In fact, right now, you have one already. It looks exactly like that. That means it is equivalent. How about this one? Well, the 13 is matching, but the 10x doesn't match. I can't simplify this anymore. It's already simplified. I'll put a little check mark to show you these are already simplified. That definitely is not matching, so I won't put a check there. Let's take a look at this one. Oh, wait a second. I can simplify this one. This is negative 2x minus 6 plus 19. I can get rid of the parentheses. No signs change because I have no negative here, and there's no multiplying anything by a negative 1. Let's go ahead and finish this up. Here's my like term. I've got negative 2x and then negative 6 plus 19. You might need to put that in your calculator. Negative 6. Look, I used the plus or minus negative. Let me clear my display first. There's my negative. We're not subtracting 2. We're multiplying 2 by negative 1. So that's a negative 2x. So negative 2x. Oh, sorry. I'm not doing that. I'm just doing the two constants. I've got negative 6 plus 19. And there we go, positive 13. So negative 2x plus 13. Well, boom, take a look. That matches my simplified expression in my equation. So that means I have equivalence. And then the last one, we've got like terms here. So x minus 3, remember there's a 1 here, so 1 minus 3 is negative 2x. And then I've got negative 2 plus 15. Negative 2 plus 15 is positive 13. And we have another equivalent expression. So the big takeaway from this is, class, the reason we learn how to simplify is because it takes equations or expressions that may look crazy different from each other, but if they're equivalent, when you simplify, you'll get the exact same expression or equation. So in this case, we found out which ones were equivalent. Your job now is to solve this one the same way and simplify this, combine like terms, and then do the same thing for all of the examples and see if you can figure out which ones are equivalent. And last thing, essential question, tell me what you know about like term. How do you determine whether something is a like term? All right, that's your guidance for this worksheet.